Hey guys, alright, here is example 8 from 9.4. Finding the actual speed of an aircraft. Excuse me. A Boeing 737 aircraft maintains a constant airspeed of 500 miles per hour in the direction of due south. The velocity of the jet stream is 80 miles per hour in a northeasterly direction. First, let's consider the difference between airspeed and ground speed. So we are going to talk about that one. Part A, find the actual speed of the aircraft relative to the ground, aka ground speed. Part B, find the actual direction in which the plane is actually heading or headed. So they give you some important information here. First piece of information, they give you airspeed of 500 miles per hour, and that is going due south. Due south is just nothing but going south. So if you see the words due east, due west, due south, due north, that's just going straight up, straight down, north, south, east, west. Next piece of information is the velocity of the jet stream. It's 80 miles per hour. Jet stream is the wind, and we will talk about that later. Northeasterly direction. This is exactly 45 degrees in between north and east. So before we go and draw out a compass, we will talk about the airspeed and the ground speed. So the difference is this. On a perfect day, airspeed is the same as ground speed. So on a perfect day, these two would be identical. That means there's no wind. But most of the time when you are flying an airplane, you're gonna have either headwind or tailwind, so some sort of wind. But if you have wind blowing at the same direction as the airplane, blowing at the same direction as the airplane, then you're going to have your formula. Then airspeed equals ground speed minus your wind speed. Okay, we can even move this around to say that the ground speed equals airspeed plus wind speed. Okay, this is just manipulation of formula. So you can do this or you can do this. Remember, the ground speed is the actual speed of the airplane. If you have wind, then your ground speed will be quicker because you need to take the airspeed and you add the wind if the wind is going in the same direction. That's called tailwind. If you have headwind, then your ground speed will be slower than your airspeed because now you have to take your airspeed and subtract the wind. So that's the difference between airspeed and ground speed. And again, ground speed is the actual speed, okay? Factoring in the wind. So part A said, find the actual speed of the aircraft, aka find the ground speed. So let's draw out our north, south, east, west. North, south, east, and west. You have an airspeed of 500 miles per hour in the direction of due south. So that's just going straight south. This vector, let's call this vector airspeed. So V subscript A. And that is going vertically down, so that's negative 500 J. Then it says you have a velocity of the jet stream. Jet stream is your wind of 80 miles per hour in a northeasterly direction. So technically northeasterly, so here's north, here's east, it's this direction, okay? 45 degrees in the middle of those. But because I'm trying to add on to my I'm trying to add on to my airspeed, I'm going to add it to this vector here. Let me move this writing to the other side. So this is v of airspeed equals negative 500 J. So instead of adding it or drawing this out at the origin, I'm just going to continue here. This green vector is vector of the wind equals 80. The magnitude is 80, okay, the velocity is 80, and it gave you an angle, a direction. So anytime you see directional, that means you're looking for an angle, and the angle is going to be this angle from here to here is 45 degrees. And remember, when you're looking for an angle, you're always starting on the x-axis. So cosine of 45 degrees I plus sine of 45 degrees J. So that's a wind vector. We have we need to look for ground speed. So we will let ground speed be v subscript g equals v subscript a for airspeed plus v subscript wind or w for wind. So this is what we're looking for. The vector of this, and then we're going to take the magnitude, and that will give us the speed. So v of a is negative 500 J plus the wind speed. I need to simplify out the wind. Ready? V of w equals 80 cosine of 45 degrees is rad 2 over 2. Sine of 45 is also rad 2 over 2 in the j direction. So v subscript w is 40 rad 2 I plus 40 rad 2 j. So that's what the vector for the wind is. So now I'm just going to add it here, behind here. Plus 40 rad 2 in the I direction plus 40 rad 2 in the j direction. Let's try to combine like terms. Final answer for the vector, not the speed. V subscript g is aka ground speed, aka actual speed is, let's put I in the front. Since there's only one I term, we are going to write I in the front. Looks like you have two j terms. That means we can put them together and then factor out your j and put it in the front. I'm not going to use the calculator to punch this in. I'm just going to leave this as is. This is the resulting vector for the ground speed. That's really not what is asking in this note. It's asking find the actual speed. So now we just have to take the magnitude. Although I will be asking for this on your test, so make sure you box this up here. So the magnitude of the ground speed vector will give us the speed. So the magnitude is a big square root 40 rad 2 quantity square, that's your a square, plus b square would be this whole thing quantity square. That's why I said I don't need to use a calculator as long as in the simplest radical form. Now I will use the calculator and punch this in. This will give us about 447.03 with the use of a calculator. So let's write a complete sentence for our answer. The actual speed is is 447.03 miles per hour. Okay, let's box that up. We just answered part A. Part B said, oh, well, okay, you know the speed. What direction is it? What angle is it going? So to find the angle, remember, you already have the the vector for the ground speed. Now we just have to find the direction of this airplane. So direction is angle. Angle is tangent inverse of y divided by x. And that's going to give us, what's y value? Tangent inverse of y is negative 500 plus 40 rad 2 divided by 40 rad 2. Okay. So take your calculator, enter that in to see if you have matching answer with me. When you enter that in your calculator, you should have a negative 82.73 degrees. Well, let's go back to our makeshift compass up here. Okay, so earlier we added, okay, this is your vector for the airspeed, this right here. And then we also did another one, another vector. We added another vector for your wind, which is the green one. When we add two vectors, we should come up with your, let's use a different color, this one. This is where the airplane is going, okay? This is your ground speed vector, the actual speed of the airplane. So that's in quad 4, which is awesome. I'm gonna make it bigger down here. So we have this vector, the ground speed, actual vector. When we borrow the calculator, we punch it in, it tells us this is a negative 82.73 degrees. Well, that means if that's negative 82.73 degrees, as you can see, this is totally not drawn to scale. Would you agree that's, let's just take whole number for the sake of simplicity. So this is about negative 83 degrees. So that means this right here, it's about 7 degrees, okay? So how do you write the answer in math? North, south, east, and west. So to verbally spell this out, this is how you write the direction. The actual direction is 7 degrees east of south. Okay, 7 degrees east of south. Because this is what's happening. Because the airplane is starting the sentence, the airspeed of 500 miles per hour in the direction of south. I mean, you go straight down, and then the wind blew it 45 degrees. So now it's going a little bit slightly east of south. So it's going, because of the wind, it's going 7 degrees east of south. Now your book is not going to spell all of that out for you. So the way that this book is it's writing is 7 degrees, east is in the back, and then south is in the front. So this is that. Okay, this is the end of your example 8.